In this series of videos, I will perform activities meant to demonstrate some of the named thermodynamic processes. In this video, I will illustrate isobaric expansion and isobaric contraction processes between different thermal reservoirs. I will try to limit commentaries. Please watch the video carefully and pause where needed. With some exception of freeze frames, like right now, the video is unedited. At the beginning of each video, I will go through an initialization step meant to set the N, that is the number of molecules in the heat engine apparatus, at a consistent value. In this initialization, I am setting the gas temperature at 0 degrees C in ice water. Placing a 500 gram mass on the piston and trying to set the piston at the lowest volume without the piston touching the bottom. This will give us the smallest N that will ensure that the piston won't touch the bottom in the course of measurement. So we will start from the cold reservoir. This is the initial volume of the gas with no additional weight on the piston. And the gas is now undergoing isobaric expansion from 0 degrees C to room temperature, about 20 degrees C. The pressure on the gas is provided only by the atmospheric pressure and weight of the piston and the platform, no additional masses. And it will now undergo isobaric contraction down to 0 degrees C. We will place an additional mass of 200 grams, which will increase the pressure on the gas in the heat engine apparatus and go through another cycle of isobaric processes. Here's isobaric expansion from 0 degrees C to 20 degrees C. And isobaric contraction from 20 degrees C to 0 degrees C. And we place additional 200 grams for a total of 400 grams on the platform. Isobaric expansion to 20 degrees C. And back down to 0 degrees C. It looks like the piston is barely touching the bottom here, so we'll stop a little bit here and reinitialize the N, the number of gas molecules in the heat engine apparatus. But I think the measurement we just did is okay. It's just barely touching the bottom. So again, we place 500 grams for the what might be the maximum pressure on the gas, and allowing the gas in, we try to set the piston at the lowest position, which won't touch the bottom. Okay, so this should be at least provide somewhat of a consistent end. We'll now look at isobaric processes between the room temperature and warm water at about 40 degrees C. We double check with the thermometer that it's approximately 40 degrees C. And here's the isobaric expansion from room temperature 20 degrees C to about 40 degrees C. With no additional mass on the piston, the pressure on the gas is just due to the atmospheric pressure and weight of the piston. And here's the isobaric contraction. And we place the additional 200 grams. And as we heat the aluminum can, the gas undergoes isobaric expansion from 20 degrees C to 40 degrees C. And back down to 20 degrees C for isobaric contraction. Finally, additional 200 grams. So now there's a total of 400 grams on the piston. Here's isobaric expansion from 20 degrees C to 40 degrees C at this value of maximum pressure, and isobaric contraction from 40 degrees C to 20 degrees C. So this is one trial of isobaric processes between ice water and room temperature, and also between room temperature water and warm water. We will adjust the parameters slightly, starting with a larger N for a second trial of isobaric processes. Thank you.